Alright folks, welcome back to Chapter 13, Part 6. It's all about geothermal energy today. We've got two sections, harvesting geothermal energy and then also ground source heat pumps. Your objective is being able to explain the advantages and the disadvantages of geothermal energy, and it should be a pretty short chapter today, or a pretty short section. So first thing to talk about is geothermal energy, and as you can imagine, geothermal energy is using the heat from a natural radioactive decay of elements deep within the Earth, as well as heating coming from Earth. So back in Chapter 8, we learned about the mantle and all of the thermal energy that moves the magma around deep underground. And in some places in the world, that heat is really close to a water that's in the ground, and that water can escape up to the surface as steam. There's the hot springs in Yellowstone National Park. Um, so that's certainly a possibility. Now that steam and that groundwater, the groundwater that turns to steam, that can be used to make electricity. And so again, the basic idea is similar to what we've talked about before with electricity generation. The steam spins the turbine to make the electricity, but this time the steam is made through through the heat of the earth. So that's the big idea there. The problem though is that we want to make sure that we're not using too much of that water. We're not extracting too much of the water, turning it to steam, and then just discarding it. Because again, we want to make sure that we're using the water in a sustainable way. So after that water is extracted, turns to steam, turns the turbine, it's much more beneficial to the environment to condense it and then return it back into the ground in the area that it was extracted from. And so that will help in terms of keeping geothermal energy sustainable. The other thing I want to talk about is a ground source heat pump, and this is going to take advantage of the high thermal inertia of the ground. So what that is that about 3 meters below the surface of the ground, that remains about 10 to 15 degrees Celsius all year. Okay, no matter the winter, spring, summer, or fall, about 3 meters below the surface is a relatively constant temperature. And what can be done is we can use that constant temperature to use that as sort of a natural cooling system in the summer when it's very hot. In the wintertime when it's very cold, we can use this as a natural heating system. Okay, and so what we've got is, and we'll take a picture, take a look at a picture on the next slide. But there's going to be a fluid that circulates through pipes that are buried underground, and in the wintertime, that fluid is going to absorb the heat from the ground, and that'll add heat to the house. But in the summertime, the fluid is going to be cooled, and that cooled from the temperature underground, and that'll pull the heat from the house as it circulates. So again, this is a picture of a ground source heat pump, and right here, number one is the compressor. Okay, and that's going to help the fluid that's in the piping system to circulate. And so if this was the winter time, heat is going to be extracted from the exchanger right here. So the heat, excuse me, the heat from the fluid will come out of the fluid here, and then as the heat comes off and is given out into the house, the fluid will cool back to a liquid, and that'll be returned down into the ground. And the fluid's going to, moving into number two, the fluid will expand as it cools, and so it'll head back down into the ground. And then once the fluid's back into the ground, it'll be warmed again, and then pumped back up to the compressor again. So again, this could be used in the winter time to heat the house. It also can be used in a similar process can be used in the summertime to cool a house. That's it on geothermal energy. Pretty quick today. So checkpoint questions. What is geothermal energy and what is its source? How does a ground source heat pump work? And what are the main differences between types of energy extracted from underground? And when is each type most useful? Go ahead and answer these checkpoint questions. Again, preferably on Edmodo, or be prepared to hand them in. And when you're finished here, you can move on to part 7, which is electricity generated from the wind.